Welcome to the Beginner's Guide to TESS Result Filtering, a crucial step in identifying promising exoplanet candidates from the Transiting Exoplanet Survey. Satellite data. TESS is a space telescope that surveys the sky for exoplanets by detecting dips in starlight caused by planetary transits. The sheer volume of data generated by TESS requires efficient filtering to identify potential exoplanets. First, understand the key concepts involved in TESS result filtering. The primary goal is to separate true exoplanet signals from false positives, such as eclipsing binaries or instrumental noise. TESS data includes information on the star's properties, transit depth, duration, and periodicity. To begin filtering, start by selecting a dataset from the TESS archive. Choose a sector or a specific star of interest and download the corresponding light curve data. A light curve is a graph of the star's brightness over time, which can reveal transit events. Next, apply initial filters to remove low-quality data points, such as those affected by instrumental issues or cosmic rays. This step is essential for improving the signal-to-noise ratio and reducing false positives. Now, focus on identifying transit-like features in the light curve. Look for periodic dips in brightness that could indicate a planetary transit. Apply a transit detection algorithm, such as the box least squares method, to identify potential transit events. Once potential transits are identified, apply additional filters to refine the results. Consider factors such as transit depth, duration, and shape, as well as the star's properties, like its size and temperature. These filters help distinguish between true exoplanet signals and false positives. For example, a deep transit with a short duration may indicate a small planet orbiting a large star, while a shallow transit with a long duration could suggest a large planet orbiting a small star. By applying these filters, you can narrow down the list of potential exoplanet candidates. Best practices for TESS result filtering include being cautious of biases in the data and algorithms, regularly updating filters to reflect new discoveries, and combining TESS data with other observatory data to validate results. By following these steps and applying careful filters, you can effectively identify promising exoplanet candidates from TESS data. Remember to stay up to date with the latest research and discoveries in the field, and always consider the limitations and uncertainties associated with TESS result filtering. With practice and patience, you can contribute to the exciting field of exoplanet discovery and advance our understanding of the universe.